So we've managed to compute averages, rolling averages, and trend lines. Let's have a look at them applied to other segments then. So for medium volume, we only need to change the selected. All the rest of the code stays the same. So we just need to change the selected value set of columns. And we can explore them in these next two examples, just show how the rolling averages really help to show what's going on. So there's the medium volume problem sales just drawn as time series. So we're just drawing the original data. When I superimpose the rolling averages on them, you can see much more clearly what's happening. So you can see something's happened to product G. I mean, you could see that on the original one actually, but it's clearer here. Something has happened to product G between April and June. So maybe that was out of stock. You can see, for example, the red one, I'm quite sure, I think that's S, is doing something quite regular, and so is the green one doing something quite regular, but the other ones are really quite noisy in the middle. So quite helpful to use these rolling averages or averages to get a sense of those things. Okay, and then we can do that with the low volume and very low volume products. So here's examples 9 and 10 do rolling averages for those things. There's example 9, I think, for the low volume, and that's again very revealing because it shows us that product D isn't available for the first half of the year, or there are no sales, nobody's buying it, whatever. We don't know that it's unavailable, but there's no sales. So maybe it's a new product that was introduced in the middle of the year, but actually it's growing really fast. So it's become very popular, but it wasn't available for the first half of the year. Whereas if we look at the very low volume, bit too much noise to make sense of that data, so we'll have to do something else with that later. Okay, the other things we can do then, if we want to make sense of that, is reduce the noise in a number of ways. So we could just show the average or rolling average, so get rid of the original data altogether, or we can extend the averaging period. So have, as I showed you with in the last video, we can have longer averaging periods, which smooths it out, makes it cleaner. And if you want to, you can, if you've got lots of noise, you can fit a higher order polynomial as a trend line. Now, so using this NumPy polyfit function, if you set 2, you get a quadratic curve. A quadratic curve is one that goes like that or goes like that, so a U-shaped curve. Or you can do a cubic, which is one that does as a sort of saddle point, so it goes up, down, up, or the other way, down, up, down. And you can even set it to polynomial degree 10, which I don't think I can describe, but it's more curvy. It's a technical term. Okay, so the higher the polynomial, the closer you can fit to the data, but the calculations become more and more accurate, and there's no real justification for thinking that it should be higher polynomials. It just looks nicer, but it doesn't necessarily mean that it's accurate. Okay, so as you increase the order of the polynomial, you can get it to fit the data more and more accurately, but it doesn't mean that it's really telling you very much. Or the other thing you could do for that plot 10 is just segment the data further to try and understand what's going on, because there's still quite a lot of columns in that data. So just to show you examples of what we could do then, here's the monthly average data. So we've taken an average over a month and drawn trend lines. So that's exactly the same as the previous example 10, but because we've got monthly data, it's much cleaner. So that's the jagged lines, and then the dashed lines are the trend lines. So they're showing quite clear trends, and they sort of fit quite well to the average data. Or you can do what here. This is showing a 28-day rolling average. That's the jagged lines, and then trend lines of degree 3. So these are cubic equations, and you can see that they're curved and they're fitting the data a bit more closely. Okay, Again, no real justification for doing that, but it does sometimes. It can sometimes help to understand the picture. Right, I'm going to finish this off, and then we'll look at stacked area plots for the end of the lecture.